Chapter 8.1, Systems of Linear Equation Graphs. Solve for y. 5x minus 3y plus 6 equals 0. What does it mean by solve for y? In this case, we're not finding the actual value because we have two variables. We can only solve if we have just one variable. So what it really is saying is isolate y. I want to get the term that has y by itself. Right now everything's on the left side. I can move the 3y to the right side of the equation by adding 3y. Since it was negative 3y on the left, I add 3y to both sides. Then negative 3y plus 3y is 0. And I have 5x plus 6 equals 3y. So the term that has y is now by itself, but we need it to say 1y, not 3y. 3y means 3 times y. The opposite of multiplying is dividing. So we need to divide all of the terms by 3. Then we get 5 over 3x plus 6 divided by 3 is 2 equals 3 divided by 3 is 1. So I'm left with 1y, or just y. And then I could write the y on the left side so that it's in mx plus b form. So instead of 5 over 3x plus 2 equals y, I can just move the equal sign and the y to this side. And then I get y equals 5 over 3x plus 2. Now the y is isolated. Graph using a table of values y equals 2x plus 3. So table of values. How do we make a table of values? Well, we make a table first. We have x values and y values. X is always first, and then y, just like the alphabet. Then we pick some values for x. I usually try to pick 1 or 2 negatives, 0, and then 1 or 2 positives. So I might go negative 2, and then I sub that into my equation. My equation is y equals 2x minus 3. So I put in negative 2 for x, I get y equals 2 times negative 2 minus 3. And then I calculate that. 2 times negative 2 minus 3. 2 times negative 2 is negative 4. Minus 3 is negative 7. I can also use my calculator. Two times negative 2 and then minus 3. We get negative 7. If we put negative 1 for x, y equals 2 times, replace x with negative 1, and then minus 3. So 2 times negative 1 minus 3 is negative 5. Put 0 in for x, y equals 2 times, replace x with 0, minus 3. 2 times 0 is 0, minus 3 is negative 3. Do x equals 1, then y equals 2 times the x value, which is 1, minus 3, which is negative 1. 2 times 1 minus 3, negative 1. And then we can do x equals positive 2, then y equals 2 times positive 2 minus 3, which is 4 minus 3, which is positive 1. And then once you have a table of values, you plot those points on the grid that you're provided with. So our first point was x is negative 2 and y is negative 7. Negative 2, 4, 6, 7. Right there. Then negative 1, negative 5. -1, and then down 2, 3, 4, 5. Then 0 and -3. So x is 0 right in the middle, and then down 1, 2, 3. Then +1, -1, x is 1, so to the right 1, and then down 1. And then x is 2, and y is 1, so right 2 and up 1. Then we can join our points together with a line. And that is the graph of y equals 2x minus 3. Next, graph using slope y-intercept. So remember our slope y-intercept form from chapter 7. Y equals mx plus b, where m is our slope and b is our y-intercept. Then for this question, we have m equals -3, which we can write as a fraction by putting a 1 underneath, so -3 over 1. And our y-intercept has a y value of 1. So it is at the point x equals 0, y equals 1. Remember, for an intercept, if it's the y-intercept, the x value is 0. If it's the x-intercept, the y value is 0. Now we can plot that point, the y-intercept. So at x equals 0 and y equals 1. It's our y-intercept. And then we have a slope of -3 over 1. So that means it's going down and to the right in this direction, whereas this one was positive slope. It was going up as we moved to the right. So from our point, the y-intercept, count down 3 and right 1. Down 1, 2, 3, right 1, put a dot. Down 1, 2, 3, right 1, put a dot. Down 1, 2, 3, right 1, put a dot. To go up, we go up and then left. Up 3, left 1. Up 3, left 1. Up 3, left 1. Then we can join our points together with a line. And that is the graph of y equals 3x plus 1. Found a couple errors while I was editing. I noticed for the second graph, when I wrote the equation at the top, I wrote y equals 3x plus 1. That should be -3x plus 1. The next method is to graph using the intercepts. So as I just mentioned, for the x-intercept, the y value is 0. So we set y equal to 0, and then we solve for x. Then our equation becomes 6x minus 2 times 0 plus 6 equals 0. A number times 0 is 0, so that middle term is gone. We have 6x plus 6 equals 0. We want to isolate the x. I have two terms here, one with an x, one without an x. I want them on opposite sides of the equal sign. So I can subtract 6 from both sides. I get 6x equals -6, because plus 6 minus 6, those add to 0. 6x means 6 times x. We want to separate the 6 from the x, so the opposite of multiplying is dividing. We divide both sides by 6. 6 divided by 6 is 1. We're left with 1x equals negative 6 divided by 6 is negative 1. So our x-intercept is at the point negative 1, 0. The y value is 0. Then we do the same thing for the y-intercept, except we set x equal to 0. And then we solve for y. We get 2 times 0 minus 2y plus 6 equals 0. 2 times 0 is 0, so we have negative 2y plus 6 equals 0. I want these two things on opposite sides of the equal sign, because one has a y and one does not. This time, since I have negative 2y, I'm going to move that. So I'm going to add 2y. And then I'll end up with a positive y value. So I have 6 equals 2y. Now I want to separate the 2 from the y. Remember, 2y is 2 times y. So to separate the 2 from the y, do the opposite operation, which is dividing by 2. And we get 3 equals y, or y equals 3, which tells us that the y-intercept is at x equals to 0 and y equals 3. Then I plot those 2 points. The x-intercept is negative 1, 0, which is here. The y-intercept is at 0, 3, which is there on the y-axis, and then I join those points together with a line. And that is my graph of 6x minus 2y plus 6 equals 0. Found another error here in the last one. I wrote 2 times 0. That's supposed to be 6 times 0 because it's 6x in the equation. It doesn't change the value of our y-intercept since it still is going to equal 0. 6 times 0 is 0, but just for clarity's sake, that should have been 6 times 0 minus 2y plus 6 equals 0. So there you have 3 different methods to draw the graph of an equation. Ordered pairs and solutions. An ordered pair satisfies an equation if, when substituted, the left-hand side equals the right-hand side. Example, does the ordered pair 6, 3 satisfy the equation 3x minus 2y equals 12? So an ordered pair is always an x value and then a y value. To check if this ordered pair satisfies the equation, we're going to sub in 6 for the x value and 3 for the y value. And then we're going to see if the left side equals the right side. Our equation is 3x minus 2y equals 12. I'm going to replace the x with 6, the x value from the point. Then I get 3 times 6 minus 2. I'm going to replace the y value with 3, the value of y from the point. So minus 2 times 3 equals 12. Then I'm just going to calculate each side. I'm not going to move anything, just calculate. So 3 times 6 is 18. You can use your calculator. Minus 2 times 3 is 6 equals 12. 18 minus 6 is 12 equals 12. So yes, the left side equals the right side. Therefore, 3 dots means therefore, the point 6, 3 satisfies the equation. So a note, don't move anything across the equal sign calculate both sides and check if they are equal. Systems of equations. A system of equations is two or more equations considered together. A solution must satisfy each equation in the system. Example, does 6, 3 solve the system 3x minus 2y equals 12 and 2x minus y equals 9? Does the point 6, 3 solve the system? What does it mean to solve the system? That means, does this point satisfy both equations? The point and the first equation are what we did on the last page, so we already checked that the point 6, 3 satisfies the equation 3x minus 2y equals 12, so we can just put a check mark. Now we're going to check if this point also satisfies the equation 2x minus y equals 9. So again, sub in 6, 3 for x and y. We get 2 times the x value, which is 6, minus the y value, which is 3, equals 9. 2 times 6 is 12, minus 3 equals 9, and 12 minus 3 is 9, equals 9. So we got the same thing on the left that we had on the right. Therefore, the point satisfies this equation, and because it satisfies both equations, then it satisfies the system. So we can say, therefore, the point 6, 3 satisfies the system of equations. Meaning that it satisfies both of the equations in the system. If it only satisfied one of the equations, then it would not be a solution to the system. What does this look like graphically? Isolate both for y and graph. So it's telling us to isolate the y, so put it in y equals mx plus b form. We have 3x minus 2y equals 12. I already have one term on the right, so I'm going to leave my y value on the left and move the 3x. It's positive 3x. I'm moving it all together, so I'm subtracting 3x from both sides. Then I get negative 2y equals, for y equals mx plus b, the x terms first, so minus 3x and then plus 12. Then I have negative 2y. That means negative 2 times y. I want to separate the negative 2 from the y, so the opposite of multiplying is dividing. Divide by negative 2, and do that to all of the terms. Negative 2 divided negative 2 is positive 1, so I get y equals negative 3 divided by negative 2. A negative divided by a negative divides out, so we get positive 3 over 2x, and then 12 divided by -2 is -6. So to graph that, we have a slope of 3/2, and we have a y-intercept of -6, which is the point 0, -6. Plot the y-intercept, 0, -6. So on the y-intercept, go down 6 and put a point. Our slope is 3/2, so that means it's positive. We're going up to the right. So from your y-intercept, count up 3, right 2, put a point. 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 Up 3, right 2. I can also go down 3 and left 2 from my y-intercept, and then join my points together. And that is our graph of y equals 3/2x minus 6. Then our second equation, isolate the y. Again, I already have a term on the right side, so I'm going to move the x term over to the right. It's positive 2x. I'm going to subtract 2x from both sides to move it over. 2x minus 2x is 0. I get negative y equals, put the x value first, -2x plus 9. I have negative y, but I want positive y. So I'm going to divide everything by -1. You can also multiply everything by -1. You'll get the same result. -1y divided by -1 is positive y. Negative 2x divided by -1 is just positive 2x. And positive 9 divided by -1 is just -9. So dividing or multiplying by -1 just switches the sign of all your terms. Then we have a slope of 2, or slope equals 2/1 for rise over run, and a y-intercept that is -9, or the point 0, -9. Plot the y-intercept, 0, -9, so on the y-axis go down 9 and put a point. Then our slope is 2/1, so it's positive again. We're moving up as we go to the right. We're going up 2 and right 1. Up 2, right 1, 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 up 2, right 1. So the point where the two graphs intersect is that point there. We can join our points with a line. And that is the graph of y equals 2x minus 9. So what is the point where the graphs intersect? That is an x value of 2, 4, 6, and a y value of 1, 2, 3. So the point 6, 3 is where the two lines intersect. Then we have this statement down here. The point of intersection is the solution to the system. So graphically, the solution looks like the point where the lines intersect. Next, using our calculators to solve systems graphically. So first step is to change the equations into y = form. In order to graph them in our graphing calculators, they have to be in that form. Step 2 is to enter the equations into the calculator for y1 and y2 and then graph. If the intersection point does not appear on your graph, you're going to have to adjust the windows so that you can see the point where the two graphs intersect. And then step 3, to find the point of intersection, you're going to do for a TI second trace 5 and then hit enter 3 times. For a Casio, you do F5, F5. Example solve graphically 4x plus 3y = 12 and 4x minus 7y = 4. First step is to write them in y = form. So let's do that. The first one, 4x plus 3y = 12. I want to isolate the y. I'm going to subtract 4x from both sides. Then we get 3y equals x value first, so negative 4x plus 12. This positive 4x and negative 4x add to 0. Now I have 3y, but I want 1y. 3y means 3 times y. The opposite of multiplying is dividing. So divide all of your terms by 3. We get 3 divided by 3 is 1, so y equals negative 4 over 3x plus 12 divided by 3 is 4. The second equation, 4x minus 7y = 4. Again, I'm going to subtract 4x from both sides. We get negative 7y equals negative 4x plus 4. Right now we have negative 7 times y. We want 1y, so we're going to have to divide all of our terms by negative 7. Negative 7 divided negative 7 is 1. We get y equals, we have negative 4 divided by negative 7. Negative divided by a negative is a positive, so we get 4 over 7x, and then we have 4 divide negative 7, which becomes minus 4 over 7. If you're not sure about the fractions, you can use your calculator. Depending which calculator you have, you can enter the fraction. This calculator app that I have on the iPad is basically a TI. So for some TIs, you can go push the math button, and then at the top, there's an option for fraction, frac at the very right. So if I go left one, that'll take me there. And then if I hit enter, n over d, that's numerator over denominator, I can write a fraction. So if I hit enter, it gives me a fraction on the screen. Depends on which type of TI you have. Not all of them can do this. But if you have the Casios, if you've borrowed a Casio from the school, they can all do this. Or if you bought the one I suggested, it should have a fraction button. On my model of Casio, it's right above the number 7. It's A and then B over C. Just push that and you can enter a fraction. So anyways, for example, if you're just not sure about what negative 4 over 7 would equal, just put it in. Negative 4 over negative 7. Enter, and it gives us positive 4 over 7. So you can always use your calculator to help you simplify your fractions. If you have a TI that doesn't have the ability to enter fractions, or a Casio, the lower model of the Casio can't do it either, you just put it in as a division. So negative 4 divide negative 7. It's going to give you a decimal. And then the Casios have a button that says F to D, so F arrow D. It's usually above the 8, around there. TIs, to change a number to a fraction, you go math, and then it says frac, the one you're highlighted, you just hit enter, enter. Oops, I hit it twice. But it changes it from a decimal to a fraction if it can. Okay, if it can be written as a fraction, it'll change it to a fraction for you. Okay, so now we have our two equations. They're in y equals form. We're going to go to our y equals, going to clear whatever you have there. Remember, you push menu and then the graph option, and then to clear something you push delete, which I think is F2 for all the models, and then delete formula, F1 for yes. Then enter in what we have. If you have a fraction button on your calculator, use that to enter your fractions. So I would use math fraction and then put my -4/3 and then move out of my fraction. This is very important. Move out of the fraction and then put the x. Then I do +4. Okay, if I don't move out of the fraction, the x is going to go on the bottom, which is not the same thing. If you don't have the ability to enter fractions, that's okay. Just enter the fraction that's being multiplied to the variable as a division in brackets. So bracket, for the second one, I'm going to do it this way. 4 divide 7, close bracket, and then an x, because it's 4/7 times x. And then minus, I have another fraction, so bracket, 4 divide 7, close bracket. Okay, so if you can't enter fractions on your calculator, that is how you would enter the second equation. If you can enter fractions, you would use fractions and write it the way it looks over here, 4/7x minus 4/7. Just remember, when you put that x, you move out of the fraction and put it beside the fraction. Otherwise, it ends up on the bottom, which is bad. Okay, so once we have those entered, we can hit graph. And I should be able to see my intersection point. If you can't, you want to change your window, right? So for TIs, you hit the window button and you can change it to whatever you want using X min and X max, Y min and Y max. So X is left to right, Y is bottom to top. Or, go back to my graph, you could hit zoom. And then there's options. You might use zoom standard, which takes us from -10 to +10 in the X direction and also in the Y direction. Or you might try zoom fit. Okay, so if you can't see your intersection point and you've tried the standard window, maybe try zoom fit. Okay, in this case, standard's going to work. For Casios, to change the window, you can do F3. Then you can change your X min, X max, and Y min, Y max. Or at the bottom, F3 is for the standard window, which is +10, -10 in both directions. So you can hit that. And then EXE again to graph. You could also do F2 for zoom. And then there's the auto is F5. Okay, so if you've tried the standard window and you can't see your intersection point, then you can try F2 for zoom and F5 for auto. But in this case, our standard window works. So now we want to find the intersection point. If you have a TI, you're going to go second trace. Intersect is number 5. And then you're just going to hit enter because it says, are we on the first curve? Yes. In this case, the curve is a line. Second curve, yes. And then guess, no, I don't want to. So I hit enter and it tells me 2.4 and 0.8. On the Casios, I hit F5 and then intersect should be F5 again. And it just tells me 2.4 and 0.8. So then I need to draw the graphs and show the solution on my grid. I'll start by doing this one, -4/3x + 4. Plot the Y-intercept, which is at +4 on the y-axis. Then our slope is -4/3. So negative, it's going down as it goes to the right. Going to go down 4 and right 3. Down 4, right 3, put a dot. Down 4, right 3, put a dot. Down 4, right 3, put a dot. If I want to go up, I go up 4 and left 3. Then I join those points together. Then I graph the next one, which is 4/7x minus 4/7. Our y-intercept is -4/7. I can go back to my calculating screen and calculate that. -4 divide 7 as a decimal is -0.57. So at about y equals -0.5. So approximately here, we're going to put a point. Then our slope is 4/7. It's positive, so we're moving up as we go to the right. +4, so up 4. 1, 2, 3, 4, and right 7. 1, 2, 3, 4, 5, 6, 7. Plot your point. And then we can join those two with a line. And then our solution point is where they intersect, which on my graph, it told me was 2.4 and 0.8, which looks pretty accurate for where I was able to graph it. So that's pretty good. Next one, same thing. We want to use our calculator. We're going to need to isolate the y, write it in y equals mx plus b, then plug the two equations into our calculator, find the intersection point, draw the graphs. First one, 2x plus 5y equals -20. I'm going to subtract 2x from both sides. 2x minus 2x is 0. I get 5y equals -2x plus 20. I have 5 times y. I want y. The opposite of multiplying is dividing. So divide all of your terms by 5. We get 5 divided by 5 is 1. So y equals -2/5x plus 20 divided by 5 is 4. Second equation, 5x minus 3y equals -15. Subtract 5x from both sides to get the y term by itself. 5x minus 5x is 0. We get -3y equals -5x minus 15. -3 times y, we want just y, so divide by -3 for all of the terms. -3 divided -3 is 1. Again, if you're having trouble with that, that's fine. Just use your calculator, right? There's no shame in that. -3 divided -3, it's 1. So if you need to use your calculator to check things, just do it. We get y equals -5 divided -3. So -5 divided -3 gives me a decimal if I didn't enter it as a fraction, but I can hit math, enter to change it to a fraction, or on the Casio, just F to D, or just enter it as a fraction if you can, and it'll give you a fraction answer. So it's +5/3 x, and then -15 divide -3 is +5. go to y equals or menu graph for Casio's, clear whatever you have or delete it on a Casio, and then enter our equations. So if you can enter a fraction, then do that. -2/5, move out of the fraction and then put your x, then +4, enter. If you can't enter a fraction, you do bracket 5 divide 3, close bracket, then your x, and then +5. Graph that, and again, we have our standard window from the last one, and we can see our intersection point. Calculate where it is. So TI's, second trace, number 5, enter, enter, enter. Casio's, F5, then F5 again. It says -0.484 and y equals 4.1936. Now we want to draw our graphs on our grid. I'll start with this one. Y-intercept is +4. On the y-axis, go up 4 units, put a dot. Slope is -2/5, so we're going down and to the right, like this. Down 2, right 5. Down 2, right 5, put a dot. Down 2, right 5, put a dot. To go up from our y-intercept, we go up 2 and left 5. And then up 2 and left 5 again. Attach the points of the line. Then graph our second one, 5/3x + 5. Y-intercept is 5, so go up to y equals 5, put a point. Our slope is 5/3, positive, so it's going up as we go to the right. Up 5, right 3. Up 5, right 3, put a dot there. Then we can go down 5 and left 3. And then we can join our points of the line. And our intersection point is here. It's at -0.48 and 4.1936. It looks pretty accurate, I would say. So our solution in this case, let's round to the tenths place, -0.5 and 4.2. That brings us to the end of Chapter 8, Lesson 1.